Hi students, now we are going to derive an expression for the moment of inertia of a uniform rod. Uniform rod means its mass per unit length is the same at every portion of the rod. So look at the picture. We have considered an axis which is passing through the center of the rod, namely O, and the entire mass of the rod is denoted as capital M and small l is the total length of the rod. Now, since it is a uniform rod, it is assumed to be made up of so many small elements, okay, like dm, whose length is dx. So first we will introduce all the terms used in this derivation. So capital M denotes what? The mass of the rod. Small l denotes what? The length of the rod. Dm denotes the mass of a small element, and dx denotes the length of the small element. So since it is a uniform rod, I told you the mass per unit length must be the same at all points. So that is denoted by the symbol sigma. So sigma is the ratio of the total mass by total length, or the elementary mass by the elemental length. So the elementary length we have taken as dx. So this ratio of m by l, which is also equal to dm by dx, is called as linear mass density. So the linear mass density remains constant because it is a uniform rod. Okay. Since it is a ratio of mass and length, the unit of linear mass density is kilogram per meter. Okay students. Now m by l is also equal to dm by dx. Therefore, the elementary mass dm must be equal to m by l into dx. Okay. Now, since all the elements are positioned at different distances from the axis, now you see the central element, one element which is in contact with the axis, for that the x coordinate is equal to 0. Similarly, the last element on the right hand side is at a distance of plus L by 2 from the center. And the last element on the left side of the axis is positioned at minus L by 2 from the center. So, one element is at the right side, on the right side of the axis is at L by 2 from the axis. And another element which is the end element on the left hand side is at minus L by 2 from the axis of rotation. Now, the moment of inertia of an element, okay, the moment of inertia of an element dm, which we have considered in this picture, which is at a distance of small x from the central axis. So moment of inertia of an element dm about the given axis, passing through O, that is equal to di. Its mass is dm into its distance is x, therefore x square. So di is equal to dm into x square. Therefore moment of inertia of the entire uniform rod, about the given axis, is denoted by capital I is equal to integral of di, that is equal to integral of dm into x square. So we are going to integrate the value of dm into x square for each and every element, ranging from minus L by 2 to plus L by 2. Therefore, the limits here it should be minus L by 2 to plus L by 2. Therefore, I is equal to, now, instead of dm, I am going to substitute m by L into dx. So, this is integral of m by L into dx into x square. So, this is equal to m by L can be taken as a constant into integral of x square into dx. The lower limit is minus L by 2, the upper limit is L by 2. Okay students, The integral of x power n dx is x power n plus 1 divided by n plus 1. Here the value of n is equal to 2. Therefore, this is now equal to m by L into x cube divided by 3 between the limits minus L by 2 to L by 2. So this 3 also is a constant, it can be taken out. So this is equal to m divided by 3L. Therefore, I is equal to m divided by 3L into now x cube. So I am going to substitute for x minus L by 2 to plus L by 2. So the upper limit has to be substituted first. So this becomes equal to m divided by 3L into x cube is L by 2 the whole cube. So this is L by 2 whole cube minus of minus L by 2 the whole cube. The lower limit is minus L by 2. So this becomes equal to m divided by 3L, m divided by 3L into L cube. So this is L cube divided by 2 cube is 8. And minus of minus will become plus. This also will be what? L cube divided by 8. So 2L cube divided by 8. So this is equal to m divided by 3L into L cube plus L cube. So this is 2L cube divided by 8. So this is equal to, now this 2 and 8 can be cancelled 4 times. So this is m into L cube divided by. So this is equal to m into L cube divided by 4 3s are 12. So this is 12L. Once again L cube see divided by L. So this will be cancelled. This becomes a L square. Therefore the moment of inertia I is equal to now mL square divided by 12. So this is the expression for the moment of inertia of the uniform rod about an axis passing through its center of mass. The center of the rod O is nothing but its center of mass. So my dear students, we have got an expression for the moment of inertia of the rod about the axis passing through its center. I is equal to mL square by 12. Suppose if you change the axis instead of the center, parallel axis about a right end or the left end, means the moment of inertia will increase. That we are going to see in the next derivation. Okay.